All right, so this video should go pretty quick. It's going to be going over page 28 in your packet. So we're just talking about terminal velocity. So terminal velocity is the maximum velocity that you'll achieve when an object falls through the air. That means if you're going skydiving, okay, when you jump out of a plane, you will start increasing your velocity, but eventually you will hit a point where that's the max velocity you'll go. Okay, because what happens is your gravitational force is pulling you down, but your air resistance is going to eventually balance you out to where you're going to be traveling, you're going to be falling at the same velocity. So your acceleration will become zero at some point. So in this problem, we're looking at an equation. We have F net equals F air minus Fg equals ma. That just means your net force is your air resistance minus your gravitational force equals mass times acceleration. Okay, which they also put in this form, A equals F air minus Fg over m. Okay, so I like to do it this way. Okay, doesn't matter which way you do it. Okay, so we're looking at what is our acceleration when it jumps out of the helicopter. Okay, so we're going to do F air minus Fg, so 0 minus 1,000 equals our mass, which is 100, times A. Okay, so I would divide both sides by 100, and you're going to get an acceleration of negative 10 meters per second squared. See? So it's okay to be negative because what's happening is you are falling down. Okay, so that acceleration is pulling you down. Okay, so that's gravitational force that's pulling you down. So as we start to fall, you start noticing the air resistance starts going up. Okay, so, and then I forgot that mass is given to you right here in the problem. So if you're wondering where that 100 went, where it came from, that's where it came from. So our air resistance starts going up. That means your gravitational force is still the same. Okay, but your air resistance is going up. It's starting to slow you down. So 400 minus 1,000 equals 100 times A. So that gives me a new acceleration of negative 6 meters per second squared. So you're starting to notice something here is air resistance is slowing you down. So when you jump out of that helicopter, your acceleration is the highest right when you jump out. Because you go from not falling to falling, and you hadn't had time for air resistance to start slowing you down. Okay, so as you start falling, that air resistance starts pushing back on you, so that means your acceleration is going to start slowing down. Okay, because what it's doing is it's starting to balance out with Fg, so that means you're going to start reaching that terminal velocity. Now, at point C, our F air resistance is equal to our Fg, so 1,000 minus 1,000 equals 100 times A. Okay, well that means my acceleration is going to be 0. So that means at point C, that is when I reach my terminal velocity. That means air resistance and gravitational force is equal out. Okay, so that means you are no longer accelerating. So when you're skydiving, the rush is when you jump out, because that's when you go from not falling to falling. So whenever you're like on a roller coaster and when your stomach sucks in, okay, when you start at the top and you start to fall, okay, that's the rush, is that first part. But eventually what's going to happen is it's not going to feel like you're falling. It's just going to feel like you're just going very fast and you're just feeling the wind going around you. Okay, so then we have our guy. He pops his parachute. So this is where you got to be thankful for air resistance. If there wasn't any air resistance, then that parachute wouldn't do anything. So now all of a sudden my air resistance starts going up because that parachute is creating more drag. So I'm going to do my 1,200 minus 1,000, okay, equals my 100 times A. So now my acceleration is 2 meters per second squared. So remember when we were falling down would be considered negative. But now all of a sudden that parachute's trying to slow me down. So that means it's slowing you down in the positive direction. Okay, it's pulling you up. Okay, so that's why your acceleration is positive, is because it's going against your motion now. All of a sudden that parachute is trying to, which thankfully, okay, your parachute's whole goal is to slow you down. Okay, you do not want to be hitting the ground, okay, going the speed that you were at your terminal velocity. Otherwise, that'd be the only time you skydived. So now our chute's starting to open even more. Okay, so we're going to increase our air resistance. So 1,800 minus 1,000 equals our mass, 100 times A. Okay, so that means my new acceleration is 8 meters per second squared. Okay, so that means that acceleration doesn't mean that you're actually going faster. Okay, it just means you're accelerating faster in the other direction. Okay, that means it's slowing down your velocity because your acceleration is going in the opposite direction. Okay, then my parachute is fully open at this point. Okay, so I have my air resistance, so 1,000 minus 1,000 equals my mass, 100 times A. So that means my acceleration is back to 0. That means I've hit my terminal velocity in my parachute. That's as fast as you're going to go in your parachute. So your air resistance has slowed you down, okay, and now it's balanced out with your gravitational force. So therefore, you're no longer slowing down, okay, and you're not going to be falling faster. You're not going to start picking up speed again. Okay, so now you've reached terminal velocity. So we're going to answer some question. When is Bronco's speed the least? When Bronco's speed is least, his acceleration. Okay, so when his speed is the least, that means his acceleration would be the most. Okay, so that means when he jumped out of that helicopter, okay, you didn't have very much velocity yet, but your acceleration was the highest because you're starting to pick up speed. But if you notice, as you start going down, okay, what happens is your acceleration starts to go down, and then your velocity starts to go up. Okay, so in which position does Bronco experience a downward acceleration? Okay, so anytime it's going down. Okay, so in this case, down would be A and B because you had a negative acceleration. Okay, in which position does Bronco experience an upward acceleration? Okay, so when is it trying to slow you down the up direction? Well, that was D and E. For when Bronco experiences an upward acceleration, his velocity is downward. Okay, so he's still falling down. Okay, so it's not all of a sudden like the parachute is making him start to float up in the air. Okay, otherwise that wouldn't be good. Okay, so his velocity is still downward even though his acceleration is up. Okay, so you're still going down, but the acceleration is going against you to slow you down. In which position is Bronco's velocity constant? So that's when you're looking for 0 acceleration. Okay, so that would be point C and point F. In which position does Bronco experience terminal velocity? Well, that's when you're no longer accelerating. So that would just be the exact same answer. Okay, so when your acceleration would be 0. In which position is terminal velocity the greatest? Okay, so terminal velocity the greatest. So I've got two options here. I only reach terminal velocity at point C and point F. Okay, when you don't have a parachute, that's of course when you're going to be going faster than when you do. Okay, so point C is when you have your highest terminal velocity. Number 8, if Bronco were heavier, his terminal velocity would be, so remember, force equals mass times gravity. Okay, so if that mass starts going up, okay, that means that for his terminal velocity is going to start going faster. So his mass makes his terminal velocity greater. Now, what we're doing is we're taking air resistance into effect here. Okay, now if you were to take a perfect situation like in a vacuum, mass doesn't matter. It would just fall at the exact same rate. But we're talking about real life here. So the bigger the object, okay, the bigger the mass here, okay, it's going to start falling faster. So think of like a bowling ball and a feather. Okay, feather is not going to fall very fast because it has a lot of air resistance. Okay, the bowling ball is going to go a lot faster because it's got the mass and less air resistance there. So in this case, if he was heavier, his terminal velocity is going to be greater. And that'll end that.